Hello, my name is Iqbal, and today I'm going to present blockchain as a countermeasure solution for security threats of healthcare applications. Our research objectives are threefold. For example, we are going to explain what are the security threats of traditional healthcare applications, and also to present blockchain as a countermeasure solution in order to secure the healthcare applications. However, there are some semantic gaps and conceptual ambiguity in blockchain as a countermeasure solution. So we set our objective to present or to overcome these conceptual ambiguities and semantic gaps by presenting ontological framework where we will present blockchain as a countermeasure solution in order to secure our healthcare applications. We followed the systematic literature review to systematically analyze the relevant literature and a domain model for security risk management, and to explore the blockchain as a countermeasure solution in three different concepts. For example, this domain model gives us three different concepts. For example, asset-related concept, risk-related concept, and risk treatment-related concept. In asset-related concept, we set our objective to identify what assets to secure in healthcare applications. In risk-related concepts, we identified what security threats are exist in healthcare applications. And in risk treatment, we are presenting how blockchain-based countermeasure solutions can help to mitigate these security threats in healthcare applications. These such objectives lead us to two main contributions. The first contribution is framework for security risk analysis that present the assets we are going to secure in our healthcare applications. And we also identify the security threats and the associated vulnerabilities that exist in healthcare applications. Also, we present in this framework blockchain as a countermeasure solution. So this framework lists various countermeasures that are related to blockchain. By using this framework, we construct ontology, blockchain-based healthcare security ontology, that eliminates the conceptual ambiguity and semantic gaps in the domain of blockchain as a countermeasure solution. Now let's explore the framework, our first contribution that belongs to the framework for security risk analysis. Blockchain has various features by default, and these features lead us to the various countermeasures that provide by blockchain in their blockchain-based solutions, or we can say like blockchain-based applications. The first blockchain feature is like the blockchain is immutable. It is decentralized, distributed, and it also has various consensus mechanisms. For example, proof of work and proof of stake. It also provides the provenance and tamper evidence. It backed by strong cryptographic schemes, and it has smart contract-based distributed access control mechanism. You can also define the permission settings, for example, in Hyperledger Fabric-based permission controls. And also, blockchain is a pseudo-anonymous. It means blockchain doesn't relate any personal information in their ledger, but they can associate with a cryptographic hash. So in healthcare applications, we identified various security threats. For example, we have data tampering, data theft, medical records mishandling, and counterfeit drugs, man-in-the-middle attack, single point failure, repudiation, insurance fraud, clinical trial frauds, and tampering device settings, for example, like IoT devices, and social engineering. Now let's explore the data tampering more in detail. So data tampering has two different vulnerabilities. First, we are going to explore vulnerability 1, which is related to weak centralized access control mechanism. By having the weak centralized access control in traditional healthcare applications, that could harm the assets belonging to healthcare database and access control, as well as the medical transactions and patient data. There are some countermeasures exist that provides blockchain by default when implementing the blockchain-based solutions. So the first countermeasure is related to blockchain-based distributed access control mechanism that build on smart contracts. By doing this one, this access control mechanism is distributed and decentralized that provide the full control on the data access. And there is access control mechanism that implement the cryptographic primitives, for example, attribute-based encryption. And these countermeasures belong to distributed access control blockchain feature. There is another vulnerability which relates to no mechanism to verify and validate the authenticity of data. This vulnerability harms the assets belonging to healthcare database, medical transactions, as well as the medical records, patient data, and data validation. There are various countermeasures to mitigate this security threat, vulnerability in healthcare applications. And these countermeasures belong to various blockchain features that provide us by default the solutions to implement and to mitigate this vulnerability. For example, blockchain is distributed. For example, the ledger is shared among various nodes, and it is only append-only ledger. So you cannot edit something, or you cannot delete something. You can only add something. And also there are consensus mechanisms, for example, proof of work, and then data validation without requiring any third party, and unique hash ID that computes by using the original data and then associated with it. And you can use it to find the data is integral or not. And there is permission settings, for example, Hyperledger Fabric-based trusted authorized nodes that build the trusted environment. And there is, blockchain is decentralized and time evident, and immutable logging and data provenance is also the features of, by default features of blockchain. Now we can move forward and we can explore the blockchain-based healthcare security ontology, which is built by using the framework which we have explained previously. This ontology eliminates the conceptual ambiguity and semantic gaps, and also build the dynamic knowledge base that helps to define the blockchain as a countermeasure solution for healthcare applications. So healthcare security ontology provides a formal information model that presents blockchain as a countermeasure solution that overcomes the consequences of misunderstanding. The ontology is dynamic, extendable, and integratable with other security ontologies. We followed an ontology construction method that has 5 distinct stages. The first one is to identify the scope and the purpose. The second one is building ontology, and the third one is evaluation, then documentation and guidelines how to use the ontology. We have used various ontology construction tools. For example, we use web ontology language, and in that we define our domain knowledge, and then we constructed the ontology by using the Protege editor. We have used Sparkle queries that help us to retrieve the information from the ontology. Then we use the palette reasoner that help us to find our ontology is consistent and there is no invalid rules. OnGraph we used to define various classifications, and these classifications help us to refine our concepts within our ontology. For example, we have created 5 various classifications: asset-related classifications, threats classifications, vulnerabilities classification, and countermeasures classification, as well as the blockchain features classification. And these blockchain features are associated with the blockchain countermeasures. For example, in asset classification, we have business asset classification and system asset classification. And both these classifications help us to refine the business assets and system assets that we have to protect within blockchain-based applications, we can say like in our healthcare applications. This is the Protege editor that help us to code our ontology in a structured manners. For example, we have already explained the data tampering example previously that exploits two different vulnerabilities and target various assets. Further, we evaluate our ontology to check our ontology is accurate adoptable. There is a clarity in our ontology, and it is complete, computational efficiency, conciseness, consistency, and organizational fitness. This ontology evaluation is based on the quality assessment criteria. Further, we evaluate our ontology by running the Sparkle queries to get the desired results. You can see in the screen the Sparkle query header we need in every query when we are going to run to retrieve some information from our ontology. Then there is a query number 1 and query number 2. The query number 1 brings the results related to threat, what are their vulnerabilities, and what type of assets they are affecting. Query number 2 presents the countermeasures and what type of vulnerabilities it mitigating. For example, when we run the query, the first query, it brings the results on Protege belonging to threat, vulnerabilities, and what type of assets they are affecting. For example, data tampering is exploiting weak access control and error-prone authenticity of the data. And both vulnerabilities we have explained previously. And the data tampering threat is also targeting some assets. For example, it affecting the access control, healthcare database, and medical transactions within healthcare applications. And similarly, other security threats. But here we are only focusing on data tampering and data theft. However, this ontology evaluation is not enough. To further refine and further check our ontology completeness, accuracy, and correctness, we have to do expert evaluations. In our future work, we will select the domain experts that will help us to evaluate our ontology to check their correctness, completeness, and accuracy. Further, we have to check the organizational fitness of our ontology. In order to achieve this objective, we are going to use a real-world use case of traditional healthcare application that will help us to provide us the evidence like our ontology is adaptable and is fit for organizational usage. Also, there are other security threats which are appearing in blockchain-based applications after introducing the blockchain technology. For example, in our this research, we find that various literature or various studies are focusing blockchain as a security tool, but blockchain is not completely proven to be secure. There are various security threats which could negate the data and negate the ledger integrity. So, in order to complete our ontology for security threats of healthcare applications, we are going to refine and extend our ontology by using the security threats that could appear in blockchain-based healthcare applications. So, in summary, we started with our threefold objectives, and based on that, we have two main contributions. The first one is framework for security risk analysis that help us to build our security ontology that is based on blockchain-based countermeasures. So in this work, we present blockchain as a countermeasure solution for security threats of healthcare applications. That's all, and thank you.